Hello friends, now we are going to prepare the simplex table number 2 from the simplex table number 1 we have already prepared in the previous lecture. Now what, as we have calculated minimum, say we determine the key column maximization objective, so the column with the highest delta J value is selected. Then the solution values are divided by the respective elements from the key column and minimum ratio is calculated. As the name suggests, we have to select the minimum value, minimum non-negative value. We are not going to select 0 or negative value. Even we will not write negative value here, but that is another thing. Out of these two, we select the minimum. So R2 or row with S2 became the key row. The element, rather common element of key column and key row is selected, that is known as key element. The role of key element is to prepare the new column in the new table, new row in the new table at the place of R2. In the new table, simplex table number 2, at the place of R2, now there will be R4. R4 will be R2 divided by 4. That is 1/4 of R2. So this is the role of key element. Entire key row is divided by key element and it becomes the replacement row in the next table. So first 4 divided by 4 it will be 1, 3 divided by 4 3/4, 0, 1 divided by 4 1/4, 96 divided by 24. This will be always equal, the same ratio will be there. And we will never write decimal values, we will always write fractions only. Now how to prepare R3? What is origin of R3? It is R1. In R1, in the key column there is 2. So first we have to multiply this replaced row by the value which is in key column. So in key column there is 2, we will multiply R4 by 2 and then we will subtract it from R1. So the formula of R3 becomes R1, that is origin of the R3 minus sign element in the key column 2 multiplied by the replaced row R4. So multiply the replaced row, replacement row by the value which is in the key column in the row which we are now going to replace here. R3 origin is R1, in the key column in R1 row there is 2, so multiply R4 by 2 and subtract it from R1. Now what happens? R1 means 2, minus sign according to formula, 2 into 4 means 2 into 1, that is 2, so 0 will come here. In R1 there is 3 minus sign 2 into R4, 2 into 3 by 4, that is 3 by 2, 3 minus 3 by 2. The result will be 3 by 2. Now in R1, in this column there is 1 minus sign according to formula, 2 into R4, that means 2 into 0, 0. So 1 will be here as it was in row 1. R1 is 0 here, minus sign according to formula, 2 into R4 means 1 by 4, 2 into 1 by 4 means 1 by 2. So ultimately it is 0 minus 1 by 2 minus 1 by 2. Now what? 60 is here, R1 minus sign 2 into R4 means 2 into 24, that is 48. So it is 12 here. Now Zj, but to have Zj we have to write the coefficients here. To write the correct coefficients here we have to write correct variables here. Now first of all, which was the replaced row? R4 is replaced row. It is in the place of R2. The variable in R2 was S2. S2 will be now gone out and the substitute will be X1. Select the variable of key column in the previous table and substitute it with the, place it against the variable of the key row. The variable of the key row is S2, that will be substituted by the variable of the key column. So X1 is here in the place of S2. But there was no change in R1 so far as the variable is concerned, so S1 as it is. Yes, remember here it will be the variable of the key column of the previous table. The variable of key row will be removed and at its place the variable of the key column will be written. Now the Cj values, for S1 it is 0, for X1 it is 40. These are nothing but the coefficients of the respective variable from the z function. Now we can find out Zj. Zj is coefficient from Cj column, multiply with all other values and columnar addition. 0 into 0, 0, 40 into 1, 40, 0 plus 40 equals to 40. 0 into 0 plus 40 into 1, 40. 0 into 3 by 2, it is 0. 40 into 3 by 4, it is 30. 0 plus 30 equals to 30. 0 into 1, 0 plus 40 into 0, 0, so it is 0. 0 into minus 1 by 2, 0. 0 into 1 by 4, 10. 0 into 12, 0. 40 into 24, 960. Now see what happens. If this is believed to be the final solution, what is the solution? X1 is 24. No X2 in the column of solution variable. That means X2 takes value 0. X1 equals to 24. X2 takes value 0. That means this table shows point C, corner point C of our graph. And if this is the final solution, Z function takes value 960. But we have to check whether this is optimal or not. We have to find delta J, Cj minus Zj, Cj minus Zj, 40 minus 40, 0, 35 minus 30, 5, 0 minus 0, 0 minus 10, minus 10. This is the case of maximization. In case of a maximization problem, to have the optimal solution, all delta J values should be 0 or negative. But this value is not 0 or negative. That means this is not the optimal solution. 24, 0 is not the optimal solution. We have to move forward to reach the optimal solution. And for that purpose, we have to follow the process. What is the process? Again, what is the objective? It is maximization. So select the highest delta J value, that is 5 at present in this table number 2. That means we have selected the column of X2 as key column. What is the role of key column? Divide the solution value by the respective elements of key column. So here it will be 12 divided by 3 by 2. So it will be 12 into 2 by 3, 8. Similarly, 24 divided by 3 by 4. So it will be 24 into 4, 96 by 3, 32. As the name suggests, minimum ratio is selected. So 8 is selected. That means row R3 is selected as key row. Column of X2 was selected as key column. Their common element is 3 by 2, which becomes the key element. This is the end of simplex table number 2. Now in the next lecture we shall prepare simplex table number 3. Thank you.